This is R.D. Sharma Solution Class 12th. We are taking Chapter 19. Exercise is 19.31 Indefinite Integrals we are taking. X square plus 1 divided by x raised 4 plus 7x square plus 1. There is no 2 there. So the process remains the same till the 7 questions what we have adopted. So we will divide numerator, denominator, every term by x square. So I'm dividing everything by x square now. So the form we need is what we are expecting. So the integration will be 1 plus 1 by x square. Now x raised 4 divided by x square will be x square. This will be 7 only. And this will be 1 by x square. Now the integration needs to be done here. We need 1 plus 1 by x square in the numerator. For that we ought to have x minus 1 by x in the denominator. This x minus 1 by x square, you already know what it opens up to be. X minus 1 by x will put as t. As I told you, x square plus 1 by x square minus 2 into x into 1 by x is the expansion of x minus 1 by x whole square. So if you add a 2 and subtract a 2, these three terms x square, 1 by x square minus 2 together will constitute x minus 1 by x whole square. So I'm just writing this term, the three term combined together in the form of x minus 1 by x whole square. 7 plus 2 will remain, which will be 9. And since we are always having a square, so that we can apply the formula. Now talking about the numerator, 1 plus 1 by x square is the differentiation what we get. So dt by dx will be 1 plus 1 by x square. That means dt will be equal to 1 plus 1 by x square into dx. So I'm just writing 1 plus 1 by x square here. And now we are ready for the translations or the replacements. So we are writing 1 plus 1 by x square dx as dt in the numerator. X minus 1 by x we have taken as t. So it will be t square and 3 square. Now this has become equivalent to the formula which can apply. Apply here x square plus a square. Dx by x square plus a square is 1 by a tan inverse x by a. X will take as a t, a as 3. So the result I am writing here 1 by a 1 by 3 tan inverse and t by 3. What was a t initially? It was taken as x minus 1 by x. So let's solve what is inside tan inverse. So x minus 1 by x by 3 will be x square minus 1 by 3x. 3 multiplied by x. Final answer will come like this. 1 by 3 tan inverse x square minus 1 divided by 3x plus constant of integration. So this is how it can be done. This is your reference. Next is x minus 1 whole square by x raised 4 plus x square plus 1. Now the question here is x minus 1 whole square. So we will just expand it and you will see when we will simplify it, 2 terms will come and that has already been covered by us. So a minus b whole square is a square plus b square minus 2ab. That is what I am applying. X I am taking as a, b as 1. So x square minus 2x plus 1 will come. So x raised 4 plus x square plus 1 in the denominator. Now if you just go back and question number 5 if you refer, it was x square minus 3x or x square plus 3x I guess. So question number 5 if you refer, and if you don't want to, or you just want to bypass this question, then you can do it, because question number 5 is almost equivalent or equal to this question. But still, those who want to recall or try to learn again, let's see. X square plus 1 we have taken together. Denominator we have separated. The other term remains is negative 2x, which I am writing right now. So x raised 4 plus x square plus 1. So this integration will be this one. Dx remains along. Here also dx remains along. So x square plus 1 by x raised 4 plus x square plus 1. I think question number 5, and there are multiple questions. Before these questions, we have solved x square plus 1 and x square minus 1 as a numerator and x raised 4 plus x square plus 1 as the denominator. So I am writing the final result here as we have done it quite a number of times. 1 by root 3 tan inverse x square minus 1, and this is root 3x. Now in the question number 5 it was 3x, so I brought it in front of integration. But here I will not take 2 outside the integration sign as a constant, because this 2x is going to come after we take x square as t. So in order to solve this I2, which is the second term of the integral we are attempting, this will be integration of 2x dx divided by x to the power 4 plus x square plus 1. Now when we take this x square as t equals to x square, this dt by dx will be equal to 2x. dt will be equal to 2x dx. So that's why I kept 2 along with this x dx. So this 2x dx can be replaced by dt for time being. X raised 4 becomes t square, x square becomes t plus 1. Now the next step is what? Just to make this t square plus t plus 1 as the perfect square. T has the coefficient as 1. So 1 by 2, we divide it by 2, square it, add it, subtract it. So this half square will be subtracted and added. So t square plus half square plus 1. This can be taken as t plus half whole square. So this has become a perfect square now. Numerator remains as dt inside the integral sign, and this 1 minus 1 by 2 whole square will give you, basically it's 1 minus 1 by 4, 3 by 4 will come. So you can write it as root 3 by 2 whole square. Oh, it's plus actually, plus root 3 by 2 whole square. Now again 1 by a tan inverse x by a. Let me write it again. Dx divided by x square plus a square will form 1 by a tan inverse x by a, which I am going to apply it here. X, we are going to take t plus half and a as root 3 by 2. So let's apply it. After integration, we will get 1 by root 3 by 2 tan inverse t plus half divided by root 3 by 2. T plus half, if you remember, t was x square initially. Now reverse replacement we are doing, x square plus half divided by root 3 by 2. So 2x square plus 1 divided by 2 divided by root 3 by 2. 2 gets cancelled. We'll get 2x square plus 1 divided by root 3. This front root 3 by 2, when it goes up, it will form 2 by root 3. So the final result I am writing, what is inside tan inverse to 2x square plus 1 by root 3. So integration has finally taken the shape like this, 1 by root 3, and tan inverse x square minus 1 divided by root 3x, that already being done, so I just presented it the way it was. The second part we have done it here, 2 by root 3 tan inverse 2x square plus 1 divided by root 3 plus a constant of integration. This is your final result. Now this is the formal solution which you can follow whenever you review or recall. The concept remains the same, 1 by x raised 4 plus 3x square plus 1. Now this question I am leaving it for you just because it has a very straightforward solution, because one of the question we have done like this, I told you you can multiply the numerator and denominator by 2. So when you divide this and multiply this 2 can be written as 1 plus 1. You can add a x square and subtract x square. That means you can write this as x square plus 1 minus x square plus 1. Denominator will come as x raised 4 plus 3x square plus 1. Here also x raised 4 plus 3x square plus 1. It is not x square, it is x raised 4. 1 by 2 you can multiply later. And this kind of integration I think you have done multiple times. It's not x square plus 1 also, it is x square minus 1. So there are two changes in the second term. It's x square minus 1 and denominator is x raised 4 plus 3x square, which I am presenting. But eventually x plus 1 by x and x minus 1 by x has to be taken as some p and q, and that has to be replaced after differentiation. And then the formula of 1 by a tan inverse x by a will be applied here. I hope this is quite clear to you. Now this question is a super strong question. If you remember, under root cot theta was the second question we attempted in this exercise. And that question I told you when we were doing it, that it's a strong question because it allowed us to present all the experience or knowledge we have about the mathematics of the previous classes also. So first we have to convert it in the form which can be applied, means the process can be applied that we have learned for this exercise. So this sine 4x and cos 4x might have come from sine square x plus cos square x whole square. When you square it, you will get sine 4x plus cos 4x plus twice into sine square x and cos square x. A square plus b square plus 2ab. In order to get this sine square x cos square x, you can add a sin square x and subtract a sin square x cos square x. That is, if you subtract a sin square x cos square x from here, you will get sin raised 4x plus cos raised 4x plus sin square x cos square x. So we can have a perfect square here along with a sin square x cos square x subtracted. That's what I can see here. So I am suggesting that this sin square x cos square x can be written as 2 sin square x cos square x minus sin square x cos square x. That will give you sin square x cos x square x. And that we will try to get it from the square we have just performed of sin square x plus cos square x. So what I am suggesting was you just add 2 sin square x cos square x and subtract a sin square x cos square x. That will form the denominator. But the first 3 term, as I told you, is just sin square x plus cos square x whole square. And these 3 we have utilized. The other term remains is sin square x cos square x. Now what is the benefit? Sin square x plus cos square x, it will be 1. So 1 square, that is 1 minus sin square x cos square x. We will utilize these 2. So now we are integrating after writing the proper term for us to initiate the easy integration. 1 by 1 minus sin square x cos square x, because sin square x plus cos square x is 1. Now divide numerator and denominator by cos to the power 4x. Remember, we used to divide everything by x square. Same way we are dividing everything by cos raised 4x. Now this numerator has to be dealt in a different way. The sec raised 4x will come because 1 by cos is sec only. Sec 4x can be written as sec square x into sec square x. This sec square x, second sec square x can be written as 1 plus tan square x. So the numerator we can write it as sec square x plus into 1 plus tan square x. Denominator will be what? This second term, you can cancel this cos square x and with one denominator cos square x. So this cos 4x, when it goes up, it will be sec to the power 4x minus, after cancellation of cos 2x or cos square x, we get tan square x. So this is how integration has formed after certain changes and replacements. Now when we put t equals to tan x here, dt by dx will be equal to sec square x. That means dx is already there. Dt will become sec square x dx. The numerator sec square x and dx we will use and put dt in place of that. 1 plus tan square x, because t is tan x, 1 plus t square will be formed. Sec raised 4x minus tan square x. Sec 4x can be written as 1 plus tan square x whole square, because sec square is 1 plus tan square. So 1 plus tan square x can be written as sec square x, and there is a square also, there is a power also. So 1 plus tan square x whole square, and tan can be written as t, that is t tan x we have taken. So now this sec raised 4x can be written as 1 plus tan square x, which is 1 plus t square whole square, minus t square, because tan square is already there. Now let me just open this up and resolve the denominator, then I'll show you in another scene. I'm just doing the denominator right now. A plus b whole square is a square plus b square plus 2ab. So 1 plus t raised 4 plus twice of t square minus t square. So t4 we'll arrange according to the orders. T raised 4, 2t square minus t square is t square, 1 will remain like that. So the denominator we will write as t raised 4 plus t square plus 1. Now you are getting somewhere near these 2 types which we have already covered in this exercise. Let me write it. So the integration, after all these kind of transformations, simplifications and replacements, we have got 1 plus t square in the numerator. Denominator has become t raised 4 plus t square plus 1. Now put this t square in the denominator, that is divide every term by a t square. This is 1 by t square, and this will be, let me write t square first. The third term I'm taking as the second, so 1 by t square. This t square by t square remains as 1. So we'll write or integrate now, because we need a t plus 1 plus t square in the numerator. For that we need t minus 1 by t as the denominator. If you open it up, you will get t is t minus 1 by 2 t whole square as t square plus 1 by t square minus 2. So you need to add a 2 and subtract a 2 here. So let's take t minus 1 by t as u, and when we differentiate this, du by dt will be 1 plus t 1 by t square. Du will be 1 plus 1 by t square into dt. And that is what we have in the numerator in this case. So I'm replacing this numerator by du, and I'm utilizing the first, third, second, and the final term, -2. This term, and this term will become t minus 1 by t whole square. And what is remaining? 2 plus 1, 3. So we can write as a perfect square root 3 whole square. So this will become u square plus root 3 whole square. This will be 1 by a tan inverse x by a. So 1 by root 3 tan inverse u by root 3 plus a constant of integration. After integration, this is the result. But u has to be replaced by t term and t has to be replaced by the tan x we have taken earlier. So if this t we can replace by tan x, it will be 10 minus 1 by 10x. Okay, 10 square minus x, you will get 10 square x minus 1 divided by 10x, but there is no use of doing that. So rather than doing that, just take this 1 by 10x as cot x and write this as 10x minus cot x. So 10 square minus 1 by 10x will not be fruitful here. There is no point actually, because it's better just to keep this as 10x minus cot x. So 1 by root 3 tan inverse 10x minus cot x divided by root 3 plus a constant of integration. This is your final answer I. Now hopefully this question is a good question. We have applied the trigonometric identities and then the replacement and finally the integration result. That is 1 by a tan inverse x by a. This is all about this exercise. Thank you so much. Have a good one.